Hello everyone. In this video, we're going to talk all about the production function. So the production function describes the relationship between the inputs the firm uses and the output that it creates. And in this, whenever we're talking about the firm, this could be a particular business, it could be a country, or any set of countries. Your problems will tell you specifically who you're calculating this for, but the production function is equal to a function of physical and human capital. So when we see that f, it determines and tells us that it is a function of these two things. For a particular country, inputs are going to be things like physical capital, human capital, and resources. And then output is going to be GDP. So you may see this written as GDP is equal to Y, which is equal to the function of K, H, K, and L. Now again, F just denotes that this is a mathematical function. K is going to be our physical capital. HK is going to be our human capital, and then L is going to be natural resources. The best way to read this is that GDP is a function of land, labor, and capital inputs, or output is a function of inputs. Now, this equation communicates the idea that GDP in any country depends on what resources are available for production, and all else being equal, more workers, which is going to be labor and human capital, means more production. Additionally, more tools or physical capital and natural resources, which are land and others, also is going to lead to more output. So keep in mind that resources do matter and they are very important. Now, growth in real investment is going to be positively correlated with growth in real GDP. So the first version of the production function that we see is going to be the Solow model. And this focused more on capital rather than on resources or labor. The reasoning behind this is that they felt that increasing the tools available would increase the output per worker, and that capital in wealthy nations exceeds the capital in developing nations. So obviously capital had to be a big deal. They also knew that periods of investment growth were going to be periods of expansion. Now, if you were to draw a trend line through these data points, it would be considered upward sloping for GDP with this calculation, but it's really not very clear whether this implies causation in which direction. So we don't know if this is 100% right. And that's looking at this particular graph here. So we have real GDP growth rate on the y-axis and real investment growth rate on the x-axis. And again, even though it is trending upwards, we have to keep in mind that correlation doesn't always imply causation, meaning that just because it looks like real investment growth rate is a driver between the real GDP growth rate, it could be an inaccurate conclusion. And because of that, we could come up with some very ineffective policies. Now, with our focus on physical capital specifically, we have to find a way to measure the impact of these resources. And to do that, economists think about what's called the marginal product. And this is just the change in output that's associated with one additional unit of input. Now, keep in mind, a resource's marginal product is going to decline as the quantity of that resource increases. So we know there's a marginal product for each input. And the three inequalities are implicitly stating that we have this ceteris paribus assumption of everything else is staying the same, and we're only changing one thing. Now, with that ceteris paribus, the NP of each unit of input is positive. And we know that if we add more of any input with this model, output would increase. But that's not always necessarily the case. And we'll talk about why a little bit later on. But for now, we're just focusing on physical capital itself. Now, one thing that we do want to keep in mind is that diminishing marginal product, and this is why the original Solow model wasn't necessarily the best one. And this is what happens whenever our marginal product of an input is going to fall as the quantity of that input rises. Keep in mind when we talked about a McDonald's and we said that adding one additional worker would be productive, two would even be productive, 3 and 4 and so on. But if we add 20 workers in that one McDonald's, they're not going to be as productive because they're kind of getting cramped. There's not jobs for all of them to do. And that's an example of the diminishing marginal product. Now here we're looking at an island and we're saying that on this island, there is a man And he is essentially climbing trees and picking fruit. With no ladders, which are going to be our physical capital here, he's only able to get 1 bushel per week of the fruit. Now, if he decides to build a bamboo ladder, the ladder is a costly investment because it does take him away from producing fruit for a whole week. But that single ladder is going to enable Chuck to pick 4 bushels of fruit per week. That means that the marginal product of the first ladder is going to be 3 bushels per week because it's going to be that change in GDP divided by that change in capital. Now, if he decides that he wants to build more ladders, we have to look at the marginal product of the second ladder, and that's going to be 2 bushels per week. So with 2 ladders, he's able to harvest 6 bushels of fruit per week. Now, a third ladder also helps produce more output, but the marginal gain declines to just 1 more bushel of fruit. The marginal product of that second additional ladder is not going to be as large because while the first ladder completely altered the way that he was harvesting fruit, the second ladder just made his job a little bit easier. He could leave it up against the tree, not as much work to do. But that marginal product per ladder is going to start declining as more and more ladders are added. And this reflects that principle of diminishing marginal product because the marginal product of an input is going to fall as the quantity of that input rises. So diminishing marginal product generally applies across all factors of production at both our micro and macroeconomic levels. And the slope of this curve overall will start to flatten out towards the top because the marginal product of the added ladders is diminishing. Now, this is not going to be special just to this example of one man on an island. It does hold true for the macroeconomy in general, and it is a very cornerstone insight of the solo growth model and a reason that they started to look for some alternatives to this model as they moved forward. Now, when we're looking at our castaway on an island, we're just kind of continuing with that. We're using the GDP function and considering him to be his own economy. So we know that GDP is a function of capital, labor, and natural resources. The GDP in this case is going to be how much fruit he can produce. Our resources are physical capital, human capital, and natural resources. So the bamboo ladder is the physical capital or the tool. Chuck's time and knowledge is the human capital, and then the fruit trees and bamboo are the natural resources. The question they ask here is, how could Chuck gather more natural resources, or will adding a second ladder help? And would adding another ladder increase our production as much as the first ladder did? And we already talked about the outcome of this in the previous slide, but let's kind of go ahead and move forward to answer those again. So the ladder helps with gathering fruit, and adding the second ladder did in fact help, but it's not going to increase the production as much as the first ladder did because of that principle of diminishing marginal productivity. That marginal product of that additional ladder is greater than 0, but the overall NP does decline as the quantity of that resource or the number of ladders increases. So Chuck is still just one person, regardless of how many ladders he has. So eventually those ladders aren't going to make a difference for him. The image on this slide is going to be kind of a real life example of the diminishing marginal product of capital. So there's a network of highways that connects all the major cities in the US, and these highways enhance our ability to transport goods and services all across the nation. So a couch that's manufactured in North Carolina can be pretty easily transported by interstate only to Ohio in less than 8 hours, mostly just via I-77. And before the construction of this interstate system, that same trip would have entailed driving on several state highways, which are often only 2 lanes and have traffic lights. So our system of highways is going to be a really major tool that contributes to an increase in our GDP overall. And if that system were to somehow close down completely, our GDP would immediately fall. Now, on the other hand, we are asking something like, well, how useful would we find an additional network of 50,000 miles of highways? So what would be the marginal product of an additional highway system? Overall, it would probably be positive, but just as adding a second ladder for Chuck on the island didn't really make as much of a difference as the first, the impact would fall short of that first existing network because it wouldn't be life-changing. It would just be an improvement to something that already exists. And again, it's just a testament to those diminishing marginal returns. Now, this slide shows you an example of the aggregate or total production function. So on the y-axis, we have real GDP. On the x-axis, we have K or capital. And again, we can kind of see here the slope of the function is positive, which does indicate a positive marginal product. But that slope also does start to decrease at higher levels of capital, and that's because of that diminishing marginal product of capital. So the slope at K3 is not going to be as steep as the slope at K2. And this means that the level of increases from the level of capital have a less positive effect on output or Y at K3 than they did at K2. Now, keep in mind, in this graph, we do hold fixed all other factors that influence output, like land and labor. And this is really kind of the important theoretical contributions at this stage are that the marginal productive capital is positive and declining. So this leads to pretty striking implications for the macroeconomy. And this forms the basis for most discussions in growth theory since like 1956. But we have a little bit of a more detailed model that we use now, which is something that we'll talk about a little bit later, which is Solow 2 and the new growth theory. So we can't only focus on this simple formulation. We have to kind of look at the macroeconomy as a whole. Something else that we want to consider is changes in resources due to natural resources or natural disasters. So we talked about aggregate production function or total production for an entire country on the previous slide, and we're here using the aggregate production function to illustrate how a major destruction of capital would affect the macroeconomy in the short run. So in this case, they're saying that if K1 is where we were before and Y1 is where our GDP was, if a natural disaster destroyed a lot of resources, our capital would go down to K2 because we lost a lot of that physical capital. And then our overall GDP would decrease as well, just because of that particular loss. Now, to wrap up this video, I want to do a practice what you know question. According to the idea of diminishing marginal product, where will capital have the highest marginal productivity? Will it be in countries that have a large amount of labor, a small amount of labor, or in countries with a lot of capital or with little capital? And the correct answer here is that it will have a higher marginal productivity in countries that have a small amount of capital. And that's because this would be one of those kind of life-changing differences, whereas in a country that had a lot of capital, it wouldn't really make as much of a difference. And we're not quite talking about labor just yet. And that's why those labor numbers don't really affect what's going on with our capital. That's going to be where we wrap up this video. If you have any questions, please reach out. Otherwise, I'll talk with you in the next one. Thank you.